When thinking of predatory animals such as foxes, most would probably imagine a vicious carnivore with razor-sharp teeth. But what if I told you that a certain fox species munches on Christmas beetles and berries? In its natural habitat, the European red fox has been known to be an expert hunter that feasts mostly on small animals such as rabbits and birds. But a study suggests that their diet may not always be so simple. In Queensland, Australia, where the European red fox is invasive, it has had to adapt to an environment that is constantly changing due to local urbanization and the extinctions of many native species. Because of this, foxes may no longer have access to what they would have eaten in their traditional dietary niches. Curious as to what they would find, a group of scientists studied the diet of European red foxes over the course of 4 years. This study found that in their invaded habitat, the diet of European red foxes directly reflects what can be found in their environment. Without abundant access to prey, foxes act more akin to scavenging foragers that will munch on everything from plants to insects such as Christmas beetles and even decaying bird and fish remains. The expansiveness of their dietary niche reflects both the fox's opportunistic foraging habits as well as the constantly changing environment in which they live.
Yael, what's your favorite animal? Mine's the giraffe.
What an incredible creature, Don. Giraffes are usually 14 to 19 feet tall, meaning they could easily look into your second-floor window. Their neck alone is 6 feet long, weighing about 600 pounds, and it only has 7 neck vertebrae, just like humans. But have you ever wondered why giraffes have such long necks?
I always thought it was to reach high branches of trees, especially acacias. The leaves up there are too far away for other herbivores. Over millions of years, giraffes evolved their neck to snack on this tasty foliage without having to compete with other animals for their food source.
And that's the main theory. There are other possible reasons, though. For one, being so tall lets a giraffe watch for predators. Another argument is that long necks help giraffes win fights. When male giraffes fight over a female, they strike each other with their armored heads and strong necks. Typically, the longer-necked male wins, passing down his genes to his offspring.
You know, I've also heard of a study that argues that a giraffe's unique body shape helps regulate its temperature. By being tall and narrow, a giraffe can keep most of its surface area out of direct sunlight, helping it stay cool. As for how giraffes got this way, another study suggests that these long necks developed through mutations of skeletal and cardiovascular genes. How do you think the baby's heart rate compares to the parents'? Newborns have resting heart rates around 100 to 150 beats per minute, way higher than that of adults. In fact, a newborn's resting heart rate is in the ballpark of the target heart rate for an adult doing a heavy workout. What gives? Why do newborns' hearts beat so much faster than adults? Part of the answer lies in the fact that babies grow so dramatically. They burn food in every cell of their bodies to fuel that growth. The process requires not only an abundance of milk, but also oxygen, and it produces large amounts of carbon dioxide as waste. Babies' hearts work overtime to keep supplying oxygen and removing carbon dioxide to fuel their amazing growth. But growth isn't the only factor, because it's not just baby animals we're talking about. Adult chihuahuas have much higher heart rates than adult elephants. Why? Chihuahuas have a greater surface-to-volume ratio. In other words, the Chihuahua has a greater proportion of skin than internal tissue, which means it loses more heat to the environment, relatively speaking, than a larger animal. Babies' hearts beat much faster than their parents', both to fuel their growth and to make up for greater heat loss to the environment. So, little hearts maintain a higher metabolic rate, pound for pound, than big hearts. We all know that outside the world of Sesame Street, big birds can't talk. However, Our own big bird, the 5-foot-tall whooping crane, can communicate in a variety of other ways. Their inability to talk doesn't mean that the tall white birds are silent. Thanks to specialized looped windpipes, their calls can be heard for miles in their wetland homes. Often, a mated pair will call simultaneously, a behavior known as unison calling. These calls allow the male and female to strengthen their pair bond and tell rival cranes and other potential threats they need to give the pair some space. If an intruder gets close, the cranes may turn to more visual displays. Whooping cranes' heads are crowned with a patch of bare red skin. Cranes warn encroaching individuals that they are too close by tilting their heads down to display this patch. They can also direct more blood flow to it, making the red brighter and the patch larger. More visible red means an angrier crane. But not all crane communication is aggressive. Whooping crane pairs which mate for life participate in a spectacular dancing display. They bow to one another, spread their wings, toss bits of grass or sticks above their heads, and jump high into the air. We believe this dance reaffirms their pair bond, which must be strong for the couple to defend the territory and successfully raise chicks. Dancing and playing also may serve as a way for cranes to blow off steam and reduce stress levels. They also may dance because it's just plain fun. Dyslexia is a learning disorder. The reader has difficulty linking a language's proper speech sounds to letters and words. The brain struggles to learn how to automatically connect a word's pronunciation with what it looks like on the page. While scientists are still researching dyslexia's exact causes, the general agreement is that a dyslexic brain has trouble combining visual and sensory information. Consider the process that our brain has to go through to read. Break down the visual word into its individual letters. Convert those letters to sounds, then blend the sounds to create the whole spoken word. The process of breaking down and blending can take a long time for someone with dyslexia. But if you're dyslexic in English, you might not have that trouble in Chinese. That's because while English is an alphabetic language, using letters as the building blocks of words, Chinese is a logographic language. A logographic language uses written characters instead of a combination of letters to represent words. In order to know how a Chinese character is pronounced and what it means, you have to memorize the image of that character. What effect does this have on dyslexia? In English, dyslexic children often struggle with the phonics approach to reading, whereas their ability to read logographically may well be unimpaired. Since logographic Chinese requires its readers to know the whole word at once, the difficulties for a dyslexic English speaker might not be as severe if they try to read in Chinese.